Hello everyone. In this video, we are going to see iron, magnet and wall question that came in November long challenge. In this question, basically we will use some data structure that we will see in the video when I will explain the question and approach that how we will solve this question. And if you have not tried this question till now, I will recommend you just go and try this question once. And after trying, if you are not able to do it or if you are not able to understand, just watch this video completely, and I will also show you the implementation as well as the approach and build logic that how we can solve this question. Okay, let's read the question. Chef loves to play with iron and magnets. He took a row of n cells and place some object in some of these cells. You are given a string S with length n describing for each valid ith character of S is one of the following. Okay, basically you have been given a string S of length n in which the character will be I, M dash this column or X. Okay, now what I denotes here, I denotes is ith cell is contains a piece of iron, M is magnet, dash is empty, and this column is sheet, and X is ISL is blocked. Okay, now what further is written that if there is a magnet in a cell I and iron in a cell J, the attraction power between cells is Pij equals to, this is the formula given basically to calculate the attraction power between iron and magnet. Suppose if there is given iron and magnet, and the index is you can say 1 and 2. Okay, now this is 1 and 2 and is the index. Okay, now the formula used to calculate the power between this 1 and 2 is this given as this: k plus 1 minus absolute value of j minus I, that will be your always positive value. Okay, that's why they have used mod here, minus the number of sheet. If I place the, if instead of I write this like this. Okay, then 1 2 3, then how many sheets are between them? One sheets are between them. So this will be denoted by this SIFIJ. Okay, now for suppose if it is I M M I, so between these two, one sheet is there. Between these two, two sheets are there. Okay, this is how you can understand this about sheet. Now the magnet can only attract if Pij is greater than 0. Now after calculating the power, the attraction power of these two, if it is greater than 0, then only this can attract, they can attract each other. Otherwise they cannot attract each other. Okay, now there are no block cell between the cells and I and J. Now what this line means that there can be sheet, there can be dash between I and M, but there cannot be X. If X is there, then they cannot attract because the cell is blocked and they cannot attract each other now. Okay, so they now, but if there is I further, then they can attract each other, but they cannot attract each other. This is what this X means here. Okay, now chef wants to choose some magnets, possibly none, and to each of these magnets assign a piece of iron which this magnet should attract. Each piece of iron may only be attracted by at most one magnet, and only if the attraction between them is positive and there are no block between them. Now what this line means, that each piece of iron may be only attracted at most one magnet. Now if this iron is getting, if the power, if the this attraction power of these two iron and magnet is this this pair is greater than 0, then they are able to attract each other. We will increase the count, the count will be plus equals to 1. Okay, but now this magnet and now this iron cannot be used to attract other magnet or other iron. Okay, any other iron. Now this magnet not attract this okay, this iron, or this, or you can say that this iron cannot attract this magnet. This iron can attract this magnet, but this iron cannot attract this magnet. Okay, and this magnet cannot attract this iron. Okay, when they have attracted each other. So this, what this line is saying, that they can be only attracted by at most one magnet, and only if the attraction power between them is positive. That is, this, after applying this formula, the value is positive. Okay, we will be given the value of k beforehand. Okay, Now find the maximum number of magnet chef can choose. Now performing these operation only, we have to find that what is the count of the maximum number that chef can choose, that maximum pairs that we can make of this magnet and iron, which are getting attracted each other. Okay, this is what this question is saying, and this question is asking. As when you will see the constraint here, then constraint is n can be till 10 power 5 and k can be 10 power 5, and the required time complexity is 1 second. So we have to do this question in nearly O of n or O of n log n. We cannot apply O of n square time complexity here. So okay, now in the first subtask there is no sheets. In the second subtask, original constraints are there. And this is the sample test cases which I will also explain. Now we will understand few test cases which will help us, or which will lead us to get the solution or get the approach for which will help us, to get the approach to solve this question. Okay, now let's see the approach. Now let's build the approach with the help of this test case, which is also given in the sample test case. Here k is equal to 10 and string is equal to MIM underscore x denotes the block cell, I is iron, M is magnet, underscore is empty cell, and this colon is sheet. Okay, now if Pij, if we get M and I, that is magnet and iron, anytime, then if the value is greater than 0, then only we can count that pair, otherwise we cannot count that pair. Okay, and once we have counted that pair, then that cannot be used. These all pointers I have explained you while explaining the question. Okay, now let's look this at this example. We have got M and we have got I at 1 and 2. Now let's calculate the Pij for this. What is K? K is 10 plus 1 minus J minus I, that is your 2 minus 1, minus number of sheet between these two. Is there any sheet between two? No, this is 0. So 10 plus 1 minus, it will be 1 only. 1 minus 1 will be 0. It will be 10. Is it greater than 0? Yes, it is greater than 0. So we can include this. Let's take a container. In this, I have included this pair. I have got magnet at 1. I have got iron at 2. Okay. These two they are attracting each other. Now this iron cannot attract any other magnet, and this magnet cannot attract any other iron. This is what the question is saying. At most one time they can attract each other. Okay, now this magnet came. This magnet is equal to 2, and we will increase the count by 1, because we have got one pair. So the count will be, you can say, C plus equals to 1. Okay, magnet at 2. Now 4, it's blank. 5x. Now when we get the block cell at 5, is there any need to check this M? Now this M can attract any other iron further, which is at 6 or 7. It cannot. As written in the question, that whenever we will encounter an block cell, the magnet cannot, or neither iron cannot, they cannot attract each other, because they are blocked. They are between the block cell. The block cell is between them. So there is no need to check this M by 2. This will also not checked. Okay, and this cannot attract this iron. Why? Because it is also already got attracted by the iron it's beforehand, which was at index 1. Now this 6 has came. At this 6, iron will be checked. We got this iron cannot attract iron. It will attract only magnet. It we moved here 8, and at 9 we checked. Okay, magnet we got here 9. Now we will again apply the formula. What is the formula? 10 plus 1 minus mod of 9 minus 6 minus number of sheet between them is 1. 10 plus 1 minus 3 minus 1. It is greater than 0. When it is greater than 0, then when we will include it, then this will also get this. Not at I, suppose I at 6 has got attracted, and M at 9 has got attracted. Now these two cannot be used. Okay, now at 7 iron is there, but there is no magnet which it can attract, so there is no use of this, and count has been increased again 1 by 1. So total number of count that we can pair that we can get for this test case is 2. only. Okay, total number of pair, this can be answer of this test case, that only 2 pair that we have got. At max we can get 2 pair, whether if this magnet, instead of this magnet, this iron is getting attracted by this magnet, then also this magnet will be not used at their axis came here, and this iron is getting attracted by this magnet, or this iron is getting magnetic by this iron, then also this only 1 pair can be counted. So what observation you can make, what observation you can make, just think of it, that's what observation you can make. We have to count only the pairs of the M and I, okay, and only those pairs whose Pij is greater than 0, okay, whose power of attraction is greater than 0. Once those pair has been counted, we will not include that in our we will not check for those pairs or those index. Those pair magnet and iron present at those index will not be further matched with any iron or magnet. Okay, so this is the explanation of the test case. Now we now there can be two approach. First approach, that I check E again and again for this Mi, this Mi, this Mi, this MM, sorry, this Mi, then I, this M, this cannot be checked. So again and again I'm traversing and checking for each pair. This I can do, but this will give us time. This will give us the error. This will give us time complexity error. The time limit will be no, because we have to do in this O of n time complexity. So now I want you to think of data structure that we can use to solve this question, data structure to solve this question. Just think of this. As we will move further, what I am giving you a hint, that as we will move further, and whenever we encounter M, we will store in it once in that data structure. Whenever we encounter I, we store in that data structure, and when they both pairs are present, then we will match them then and there only, because we have to count pair only. So just think of that data structure. Okay, now I hope that you would have much thought of the data structure, that we can use Q. We can use Q to solve this question. Now why I am saying that, that there is index 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now in Q we can use 2Q, which suppose it's Q1 and Q2. Let's make it like this, in which we will store the, in Q1 I am storing the index of M, in Q2 I am storing the index of I, that is iron. Here I got the index of M, that is your 1. Okay, and whenever I get 1 in this Q1, then I will check that is there any index present in Q2. Is there any index present in Q2? It is not present. Okay, now again I will traverse, and here I got this I, it will be inserted here, this is 2. Now this will check, is there any index present in Q1? Yes, it is present. Yeah, now the production, sorry, attraction power will be calculated. When attraction power will be calculated, we will get that yes, it is greater than 0. It is, if attraction power is greater than 0, we will remove this also from Q and this also from Q, and we will increase our counter. Okay, this is what we can do. Now again, we have got this Q. Okay, 3. Now 3 index 3 will be stored. Now at dash we will simply continue, because there is no. Now but what will happen when we encounter X? When we encounter X, is there any need now to store the values in a queue? If suppose there is, if suppose in any example there is also some value present in Q2 and there is also some value present in Q1, is there any need to store them when we encounter X? Because they must have been either of them must be empty, before that they have been matched otherwise. Okay, so they will be removed, the Q1 will become empty. We will simply empty Q1 also whenever. So whenever encounter X, empty both Q, this we can say, because then there is no need to use that index. Okay, now I came, then I is stored here, 6th index is stored in Q2, 7th index is stored in this Q1, sorry, Q2, then sheet, at sheet is present, then sheet will be counted. Okay, I will also tell you while implementation that how we are going to count the sheet. Okay, when I will show you the implementation, then these things will become more clear. Now, when we encounter M, then 9 will be inserted. Now it will check that any is 9 and 6 can, that 9 and 6 can, the production of, sorry, attraction power of 9 and 6 is greater than 0. Yes, it is greater than 0. When it will be greater than 0, again c plus equals to 1. But what if it is not equal to 0, not greater than 0? If it is less than 0, what we will do? We will check for 7. So we can say that whenever we will encounter m, whenever we will encounter that, if our character is equal to m, then we can say that while q2 is not empty, we will check for each index present in q2. That at any time if p is greater than 0, then we will increase the c plus, we will also apply the p formula here at any time, and this p is greater than 0, we will increase the count. Okay, and if the p is greater than 0, then we will remove that both, we will remove that both index from both q, from q1 also and q2 also, and we will simply break. Otherwise, what we can see, what we can do, we can simply remove from only q2. Because why remove from q2? Because when the production, when the power, attraction power of this m at index 9 is not matching with, is less than 0 for 6, then of course after 9 we will only get 10 only, because we are traversing in increasing order. So it's obvious that for 10 also the production will be less than 0. So we can just remove this thing. If it is not, if it is less than 0, we will just remove this thing. So this is what the approach that we can use to solve this question. Now in this whole approach where we can calculate the sheet, whenever we get q1 and q2, it is not empty, we can calculate sheet from q1 to q2. We can do in, because we are storing index, what we are doing, we are storing index, we can use q1 dot peak and q2 dot peak. We can traverse till i1 is I is equal to q1 dot peak to q2 dot peak, and we can check count the sheet, and whenever we encounter sheet, we will increase the sheet. Suppose it is denoted by sheet, we will increase the count by sheet plus plus. So this will, then we can use in that in our formula, that formula that I have written here, this can be used. Now the whole thing I have told you, the everything, every approach, this I have the, in this approach I have told you everything, that what we will do, how we will use this q1, how we will use this q2. Again the same thing we will perform for q2 also. When we encounter I, then q1 will be checked. When we encounter m, then q2 will be checked. And whenever p is greater than 0, we will increase our count and we remove the both the from q and break it. Okay, this is what approach we can use to solve this question in O of n time complexity or O of n log n time complexity, you can say. Okay, the Q data structure will be become very handy to solve this question. Okay, now let's see the implementation, then things will become more clear. Now see the implementation for this iron magnet and wall question. Here I have taken the input, that is the test case input. Then I have taken the input in n and k, that is the number of length of a string, n in n, and the k that will be used in the power formula, sorry, attractive power formula. And string s, then I have taken, then I have taken 2q, sorry, when one will store the index of iron and one will store the index of magnet. This set thing you can ignore, this thing that I have written like this only. And then we can use a sheet to calculate the sheet and answer that, where we will increase our counter whenever we get the pair. Okay, and now I am calculating in this char, I am current character at ith index of the string. Now if it is I, then I will store in this first q. And now while my second queue is not empty, I will peek for it. Okay, I will get the peak element, and I'm getting the sheet from that I have told you. I will get the sheet from this second queue, second peak element of this magnet element to the peak element of the iron. Okay, character. Okay, and we will count it. If the ch, if the character is this column, we will increase this counter of sheet. And whenever, now we will apply the formula, apply the sheet, the value of the sheet in the formula, and we will get the absolute value of I minus d. What is I here? I is the current index, and what is d here? D is the peak value index, that is the magnet index. If it is getting I'm iron, then I'm also calculating the index of magnet. which will be stored in the second queue. And if it is greater than 0, I am increasing this count of my pair. Okay, and I'm removing the both from my this queue, and I'm breaking this loop. Okay, because one magnet and one iron can only attract each other. They cannot be one, more than one magnet cannot attract each other. Okay, else I will remove from second queue. I have told you the explanation of this thing, that why I will remove this from second queue, from the magnet queue, when I am encountering iron. Why? Because if this iron can, if the production, if the power, attraction power of this iron with this magnet is less than 0, then we will always encounter greater than this index. Then always this power will be less than only from 0. That's why I'm using q. Then I will remove this thing. Okay, the same thing I'm using with the help of when the character is m, that is when magnet is getting encounter. The same thing I am doing. Okay, the only thing is that I'm changing from q1 to q2. Rest is same, the whole thing is same. And whenever I'm getting this x thing, that is the blocking thing, the blocking cell, I'm clearing both the queue. There is nothing, there should be nothing in the queue, because then they cannot encounter each other. They cannot form a pair, because the cell will be blocked. And at last I will print the answer. As you can see that this is passing the both the subtask for the given question.